Hey, gang. All right, we're doing section 9.2, the parabola, and let's just jump right in. Remember that the parabola is a conic section, and it is formed by the intersection of a right angle with a conic, not a right angle, a plane with a conic section, and the plane cuts through it at an angle that intersects the bottom. Okay, and we're going to analyze parabolas that are at the origin. We're going to analyze parabolas that are not at the origin and solve some real life applications of them that are kind of interesting. You've been working with parabolas for a while, but in Math 110 with me, we worked with them when they were the kind that opened up or down because those were the functions. So we work with this kind and we work with this kind, parabolas that opened up and down. We did not work too much with ones that open right or left because those were not functions, but they are parabolas that have some real life applications. So we're going to deal with them all. If they open right, here is the general equation. Y minus k all squared equals 4 times a x minus h. The a value for all of these is going to be the distance from the vertex to the focus or the vertex to the directrix. The hk value is always the x and the y value for the vertex, okay, for the vertex. If it opens left, same thing, y minus k all squared, except now our 4 is negative, and that's for the left, positive for the right. If it opens up, we have x minus h all squared. If it opens left or right, it's y minus k all squared that starts us off. If it opens up, x minus h all squared equals 4a y minus k. And down, y minus h all squared equals negative 4a y minus k. Now, in Math 110, when they opened up and down, we had a different form. We had it as y equals some a value, x minus h all squared plus k. All right, but now we're putting the k on the other side, and we're dealing with the a little different. What we'll find is that 4 times some number, and we're going to call that number a, will define how wide our parabola is. All right. So this, I just only point that out to say that this is actually the same thing that we used if you took Math 110 with me when we were dealing with graphs of quadratics, except it's written in a different form. All right. So these look a little more terrible than they actually are. So let's just start off and graph some. So let's figure out the equation of a parabola with a vertex at 0, 0 and a focus at 2, 0. Now I'm going to use graph paper here, and I highly suggest you do as well. Let me get this guy focused for us. Let's see. Can you see that? Okay. What happened to my menu? Let's focus this guy. There we go. Get him a little bit more focused. You can do it a little brighter. All right. So we're going to draw us axes. And my problem told me, oh, I need a keyword. Last time was a black squirrel or a fox squirrel. I think today will be your we're just going to go old school today, and we're just going to say a pet. Let's do a, gosh, it's so lame, but let's just do a house cat. You know I'm running out of animals when I'm down to house cat. Today's keyword is house cat. All right, so we're back over here. We had a vertex at 0, 0. Okay, vertex is 0, 0, and so that's your h and your k value. And we had a focus at 2, 0. So x is 1, x is 2. Here's my focus, 2, 0. All right, well, if you have a vertex here and a focus here, then your graph is opening to the right. And so that's the kind that is y minus k all squared equals 4 times your a times x minus h all squared. I mean, just x minus h. All right, so my h and my k is 0, 0. So I'm just at y squared equals 4 times a. Your a is the distance between the foci and the vertex and the foci, or the vertex and the directrix. And our a in this case is 2. So we've got 4 times 2. Our h was 0, so 4 times 2 times x. So y squared equals 8x. Now there's one other thing we're interested in called the latus rectum. Get your giggles out now, please. Rectum just meaning opening. And the opening is defined by finding the 2 points on the parabola that are in line with the foci. So our focus had an x value of 2. So let's plug that in for x. And we get y squared equals 8 times 2. So y squared equals 16. Take the square root of both sides. Y equals plus or minus 4. These will be the 2 points that go with the x value of 2 on the latus rectum. So 2, 4, and 2, -4. And that makes sense when you graph it. 2, 4, and 2, -1 and 2, -4. I'll sketch that with blue. This then defines the size of the opening of the parabola, the latus rectum. Get your mind out of the gutter. All righty, there you go. All right, back to our PowerPoint. And sure enough, this is what we have here. How about equation of the parabola with a vertex at 1, -2 and focus at 2, -2. All right, so now we got a little difference, not at the origin. All right, so let's do it again. Same thing, draw our axes. And I was told that I had a vertex at x is 1, y was -2, okay, vertex. Okay, 1, -2. And my focus was at 2, -2. All right, so then mine is going to be opening to the right again. Okay, something like that. This is my HK value. All right, my A value is going to be 1. Okay, my A value is going to be 1 because that's the distance from the focus to the vertex, or excuse me, vertex to the focus. Vertex is on the parabola, focus is within the parabola. All right, so again, got some y minus k all squared equals 4 times a x minus h. My k value was -2, so y minus a -2, y plus 2 all squared equals 4. My a value is 1, so 4 times 1 is 4. X minus my h value is 1, x minus 1. So this is my equation. The one other thing they wanted us to find is the latus rectum. All right, now, again, it's going to be in line with my foci. So I want an x value of 2. So I'm going to put in x is 2 into my equation. All right, so y plus 2 all squared equals 2 minus 1 is 1. 4 times 1 is 4. Now to solve for the y, take the square root of both sides. So square roots undo squaring. Y plus 2, therefore equals plus or minus square root of 4 is 2. So this is basically y equals plus or minus 2 minus 2. So that's going to be positive 2 minus 2 is 0, and -2 minus 2 is -4. So then what are my two values for my latus rectum? Remember, we were using the x value of 2, okay? So when x is 2, y is 0 or y is -4. So 2, 0 or 2, -4. 2, 0 is here. 2, -4 is here, and that gives me the opening and shape of my parabola. You're welcome to stop me or slow me down, depending on what you need. And let's get that picture there. There you go. That's our house. All right, Tay. Now, if you just have the vertex of 0, 0, and you're opening left to right, you're going to be y squared equals 4ax. So no x minus 8. Excuse me, y'all aren't boring me. I need some caffeine. All right, now here's a different kind. X squared equals -8h. X squared, and we want to analyze this one. All right, this one then, x squared equals -8y. All right, so think of this one in the form x minus h all squared equals, got a negative, so we're going to have a -4 times some a times y minus k. That's kind of the basic one. So our h and k are 0, 0. So our vertex is at 0, 0. And if it's -8y and -8 equals -4 times a, our a value is 2. Okay. So there's a lot then you know about this. If your a value is 2 and your vertex is 0, 0, and it starts with an x squared, so that means it's going to open up or down. These are the traditional function parabolas. All right, it's going to open down though with that negative, and it's got a vertex of 0, 0, so we're going down. So that means then our focus is 2 units down. Our direction would be 2 units in the other direction. So this is our focus at 0, -2. And that's our vertex at 0, 0. All right, so then what about our lattice rectum? Okay, let me write down my focus. As we said, 0, -2. Our directrix is y equals +2. Then I want the values that lie in line with the foci. That's where the lattice rectum is. It's in line with the foci. Now I'm going to go left, right. So I'm going to use this y value of -2, and I'm going to plug that into our original. Here's our original. X squared equals -8y, and I want to plug in -2 here. X squared equals -8 times -2. So x squared equals +16. So our x therefore must equal ±4. And so that would give us a lattice rectum of 4, -2, or -4, -2. Okay. 1, 2, 3, 4, -2, -1, -2, -3, -4, -2. All right, so then our lattice, our parabola is opening up like this. All right, you're welcome to pause me and ponder that if you need to. Going back to our PowerPoint. And you see it there. All right, how about the equation of the parabola with a focus 0, 3 and a directrix line y equals -3. So this time we're not telling you vertex. We're not telling you too much about the parabola, but the things that are not on the parabola that help you define it. So we were given, oops, excuse me. Not better. Yeah. All right. So we were given a focus of 0, 3, and I think it's still not quite right. It's a little better. And a directrix of y equals -3. So let's graph that out a little bit. 0, 1, 2, 3. X is 0. No, x is 0, y is 1, 2, 3. So that's your focus, F. And your directrix is at y equal -3, 1, 2, -3. It's your directrix. All right, so we know a good bit about that because of the vertex is right smack in between the two. So right here at this halfway point, so our vertex is actually at 0, 0. So our H and K are going to be 0, 0 because our vertex is 0, 0. All right, and what way are we opening? We're opening up, right? Because you open toward your foci. So I then know that this is x minus h all squared equals 4a y minus k. It's opening up. I know my h and my k, so now I've got x squared equals 4ay because my h and my k are 0, and I know my a value. My a value is 1, 2, 3. It's the distance from the vertex to the foci and the vertex to the directrix. So my a value is 3, so I've got x squared equals 12y as my equation. Now, still need to do my latus rectum. And so that's going to take the value of the focus, and my goal is to find the points that lie in line with the focus to define the opening of the parabola. All right, so my focus is x is 0, y is 1, 2, 3. And that's what I want. I want along the lines y equal to 3. So I need to substitute in 3 for y. I get x squared equals 12 times 3. So x squared equals 36. Take the square root of both sides. X equals plus or minus 6. So my latus rectum then is going to have x values of 6 and -6 and a y value of 3. 6, 3, 1, 2, 3, 4, 5, 6, 3, and -6, 3, -1, -2, -3, -4, -5, 6, 3. We'll use that. Love to be a better drawer, but I am not. Nevertheless, you get the idea. All right, one more, and then we'll do a few applied problems. Okay, so we have a vertex at 0, 0, and we know one point on the graph, -1, 4, and we know the axis of symmetry is the x-axis. All right, so let's think about that a little bit. The axis of symmetry is the x-axis. All right, so let's look over here. Okay, once again, I'm going to draw me a little something or another here. All right. Vertex at 0, 0. Axis of symmetry is the x-axis. So we're either moving going right or we're going left. And we know this one point on it, which is when x is -1/4, y is 1. So it looks like we are going in this negative direction. All right, so because this x-axis is the axis of symmetry, I think I'm going like this, and that would have me y minus k all squared equals -4 a x minus h. So my vertex is 0, 0. Okay, so 0, 0, that's my h and my k. So now I'm down to y squared equals negative 4ax. However, that's all I know. I don't know my a value because I don't know my directrix. I don't know my focus. I do know one point on my line. When x is negative 1/4, y is 1. So I can plug in negative 1/4 for x, 1 for y, and then solve for the a. Times negative 1/4. Okay, so 1 squared then is going to equal, and 1 squared is just 1, right? Negative 4 times 1/4, that's just going to be positive 1a. So my a just equals 1. My a equals 1. So what is my equation then? My equation is going to be y squared equals negative 4x. So it worked out pretty simply. In which case, if a is 1, then, you know, there's my foci, there's my directrix, and I know all kinds of things then about my equation and the graph. All right, and just in case you forgot, we're just the regular old household cat is our keyword today. All righty. Now, you can be given these in a form that does not look like anything you recognize. This is not the end of the world. So let me just work this out here. It's a lot easier for me to write on here. So we were given x squared minus 4x minus 4y equal to 0. All right, well, which way is this one? This is going to be an x minus h all squared, not a y minus, because I don't have a y squared, but I do have an x squared. And we're going to have to do that nasty old thing which nobody likes, which is called completing the square. I'm going to put the 4y over on the other side. Do you remember when we were completing the square previously? You take your coefficient of your x term, divide it by 2 and square it. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So I'm going to add 4 to this side. But if I do it to one side, I've got to do it to the other side. This gives me on the left the perfect square, x minus 2 all squared. And on the right, let me factor out this 4. And that leaves me a y plus 1. Oh my goodness. This looks like something I can totally analyze. My HK, my vertex is going to be 2, negative 1. That's my HK. That's my vertex. Okay. The H is 2. The Y is negative. The K is negative 1. I've got 4 times some A value, which equals 4. So my A has to equal 1. So this one is going to open up, right? And with this vertex at 2, negative 1, the focus will be 1 up from that. So that'll be 2, 0 would be my focus. And my directrix would be at y equal negative 2. All right. Now let's talk about the kind of applied problems that you can use with parabolas. Suppose that a mirror is shaped like a paraboloid. Okay, a surface formed by rotating a parabola about its axis of symmetry. If a light or any other emitting source is placed at the focus of the parabola, all the rays emanating from the light reflect off the mirror in lines parallel to the light, and this principle is used to design searchlights, flashlights, some automobile headlights. Okay, where else? You can do it in the opposite direction with the telescope. So suppose that the rays of lights or some other signal emanate from a distant source, like an alien ship out outer space. It's trying to see if there's any life outside of there. When the rays strike the surface of a parabolic mirror, whose axis of symmetry is parallel to those rays, they are reflected to a single point at the focus. And this principle is used to design solar energy devices, satellite dishes, mirrors, and some types of telescopes. All right, so let's think about a satellite dish. All right, we're going to have a satellite dish that's shaped like this paraboloid of revolution. The signals that emanate from it strike the surface. Well, the signals that come from the satellite strike the surface of the receiving dish and are reflected to a single point where the receiver is located. If the dish is 6 feet across at its opening and 2 feet deep at its center, where should we place it? It needs to be placed at the focus. Okay, so we need to know where is the foci. All right, so 6 feet is the opening of the dish. And let's think about that a little bit. If we graph this one on a graph, and let's let the vertex be at 0, 0, okay, and we know it's 6 feet across, and the one other thing, we knew it was too deep. Okay, at 6 feet across, it's 2 feet deep. Then we know what these points are here, -3, 2 and +3, 2. Now, we do not know that those are the latus rectum at all, so don't confuse those with the latus rectum. All right, and we want to know where in here we need to put the foci. So what we're going to do is we know the x value of the foci will be at 0, 0, but we don't know what the y value would be. However, on our parabola, we do know a point. We know the point 3, 2. We know the point -3, 2. So we can take the basic idea, which it'll be x squared, x minus h all squared equals 4a, y minus k, but our hk is 0. And then we know 3, 2 is one of the points on the graph according to how we drew it. And so we can substitute that in. 3 squared equals 4 times a times 2 and solve for a. In other words, 9 equals, pardon me, I need to get a better pen. 9 equals 8a. Okay, so a then equals 9 divided by 8. That's 1 1/8 foot. All right, that's how far up from the vertex, from the 0, 0, from the base of our parabola, how far up you should the focus would be. So if you put the receiver 1 1/8 foot or 1 foot, 1.5 inches from the base of the dish, or you could say 1 foot and then 1/8 left over. 1 is to 8 as x is to 12. This is 12 divided by 8. Which is 1.5 inches. That's how they got that. So 1 foot, 1.5 inches. Alrighty. Well, that's, I don't know, maybe not the easiest. I like this chapter because there's a lot of good application. I hope you were able to follow along there. But now we really get into some of the tools that if you are ever struck on the remote island after you fell off the back of the cruise ship, that you're getting more information so that you can better build your parabolic structure to focus around the fire from the odds and ends left by the Japanese after they abandoned the island during World War II in the Pacific, in order to be able to build your parabolic structure to attract the cargo ship that's coming by. All right, we want you equipped in such a situation. All right, hey, Siamese cat, or no, it's just generic cat keyword today, and we'll see you later. Bye.